Hello everyone, myself Pranav Kumar and I'm going to tell you about BJT transistor today. So first of all, we will talk about transistor. What is a transistor? So transistor is nothing but an electronic device that used as an amplifier and also as an electronic switch. Why it is used as an amplifier? Because it converts the low input signals into a very high load power signals. So we consider it as electronics device that amplifies low input signals to high power load signals. Okay, and it also used as an electronic switch. So now we know that the transistor is an electronic device that amplifies the low input signals to high power load signals, and it also uses an electronic switch. Basically, the transistor is of two types. The transistor that we are talking about is of two types. The first one is BJT and the second one is FET. Okay, but today we will talk about BJT only. So let's move to our topic BJT, that stands for Bipolar Junction Transistor. Why it is called bipolar? Because the current carriers that are present in this transistor are both the electrons and holes. That's why it is called bipolar, because the carrier present in this transistor are electrons and holes. That's why it is called bipolar. So the BJT is a three-terminal semiconductor device made of P-type and N-type materials. As you can see, the BJT is of a three-terminal semiconductor, and all the regions of this transistor is made up of P-type or N-type materials. Okay. So if I have to illustrate you, let me make a diagram. Okay. Consider it a BJT diagram having three regions. First one is emitter, second one is base, and third one is collector. The base region is little thinner than the emitter and collector. That's why you can see it that thin. So in this one is our emitter, this one is our base, and this one is our collector. Okay. So you can see the three terminals are, first one is our emitter. Emitter says it is heavily doped to inject charge carriers. It is heavily doped. That means the carriers that are present in this region, the amount of carrier that is present in this region is very large as compared to other regions. The carriers that we are talking about are electrons and holes. Okay. So emitter is what? It is heavily doped. That means the amount of carriers that are present in this region is very large as compared to others, uh, and it injects charge carriers to the base region. Okay. The next one is our base. The base is thin and lightly doped to control the flow of carriers. Points are thin, lightly doped, and it controls the flow of carriers. Okay, so this region is very thin and it is lightly doped. That means the amount of carriers present in this is very less as compared to both the regions, and it controls the flow of carriers due to its doping. We can control the flow of carriers that we will talk about uh, in in the working of the transistor. So let's move to the next one, that is collector. Collector is nothing but the region that collects the carriers and is moderately doped. So the carriers that are present in base region will move to the collector region, and it is moderately doped as compared to the both the regions. Okay. So these our three regions that are present in our transistor. So next is our types. What are the types of BJT transistor? The first one is our PNP and the second one is our NPN. How we are differentiating the types of transistor? By the materials that we are using for collector, emitter, and base. As you can see, in PNP we are using a P-type material for our collector and emitter, and N-type for our base. Whereas in NPN, we are using N-type material for our collector and emitter and P-type for our base. So basic difference in PNP and NPN is our material that we are using for collector, emitter, and base. And the second one, you can see the symbols, the emitter current is going inside. and in NPN will outside. So this is our types of BJT transistor. Next, we will talk about the working and the flow of electrons in BJT transistor. So let's move to that slide. So now we will talk about the flow of electrons in BJT transistor, how the electron flow in BJT transistor, and how current produced. So let us start. So first thing I want to tell you that the amplified output. So we want amplified output from the transistor, right? So to get the uh, amplified output, we must connect the EB junction into forward biasing and the CB junction to reverse biasing. I mean to say that it is very must to connect the EB junction to forward bias and the CB junction to reverse bias to get the amplified output. Okay. Now, as we are connecting EB junction into forward bias, and we studied earlier that the carrier present in the emitter region is very large. I mean to say it is heavily doped. Emitter region is heavily doped. That means the amount of carrier present is in this is very large. So what will happen is that the electron will start flowing from emitter region to base region due to the forward biasing of EB junction. Okay, so what will happen? Uh, current flow from emitter to base due to forward biasing. Okay, the first thing. What will be the first thing? First thing will be the electron will start flowing from emitter region to base region due to the forward biasing. And as we know that the amount of carrier present in the base region is less as compared to the emitter region. So what will happen if we are saying that the electrons are flowing from emitter to the base region, and there is holes present in the base region. So what will happen? The electron will recombine with the holes that are present in the base region. But the amount of recombination, there are some electrons left after the recombination because the amount of carriers is very large as compared to holes, as we studied earlier. So what will happen? Many electrons get recombined. Many electrons will get recombined with these holes, but some electrons are left after recombination. So what will happen? The recombined valence electrons will start moving from base region through the base region to this metallic lead. But here it is valence electron, but due to the metallic lead present here, it will convert into a free electron. And then the electron will start moving towards the emitter. Okay. So I mean to say that the electrons that are coming from emitter will recombine with the holes present in the base, but some electrons get left after recombination due to the large amount of electron present in the emitter. But the recombined valence electrons will start flowing towards the metallic lead that are connected to the base region and will convert it into electron and will start moving towards the emitter. Okay, the electron will start moving from the emitter. So the second step, what will happen? Second step, recombination. Okay, recombination. Okay, recombination. Uh, of holes and electrons. Second step will be this: with some electrons get left due to its large amount. Okay. The third step will happen. What we'll talk is that the recombined valence electron moves through the base region recombined valence electrons move to through base region and what forms recombination current. Okay. So recombined valence electrons will move through the base region and forms the recombined current that is known as IB current, base current. IB current, base current is also known as recombination current. So after recombination, the recombination current start flowing towards the emitter. So now the lefted electrons will start moving towards the collector region due to the polarity, the positive charge that is present. So it attracts the electrons from base region. So electron get attracted towards the collector and start moving towards this side. Okay. So current IC is in this side. And all three currents are diffusing current. As we can see, due to the concentration of electrons, the concentration of the carriers or the electrons are flowing. That's why it is called a diffusion current. So now the electrons get the fourth step, lefted 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 electrons that sorry, that did not get recombined will move to collector. Okay, left electron that did not get recombined will move to collector and forms collector current. Okay, so this is how the electrons flows from emitter region to the collector regions in BJT transistor, and then the electrons. These are the steps. Mm, and basically, what I mean to say that the electron will flow from this emitter region, and the holes are present that are present in this region. There will be more electrons. Some get recombined, some will get recombined. The holes, some will left recombined. Okay, what will happen? The recombined will flow from this to this, and the electron will move to collector region. Okay, and then electron will move the this side and get to emitter. Okay, and from here it also move this side and move to collector. And this is how the whole process. So this is how the BJT, the flow of electrons in BJT works. So now we will move to our next topic. So now we will talk about the modes of operation in BJT transistor. So modes of operation basically means the how we are biasing the junction of the region in the transistor. As we can see, in active region, the emitter based junction is in forward bias and collector based junction in reverse bias. So when you can say in active mode of operation, the emitter base junction is connected in forward biasing and the collector base junction is connected in reverse biasing. So you can see that it is in forward biasing and it is in reverse biasing. As I said earlier, If the emitter base junction is connected in forward biasing and the collector base junction is connected in reverse biasing, then it is the condition for the amplified out. That means the in active mode of operation, it is work as an amplification mode. Amplification mode, where we get the amplified output from the transistor. Now, what mean by the cutoff? Cutoff in cutoff, as we can see, both are in the reverse biasing. That means the emitter based biasing is also reversed, and in collector it is also reversed. So as we can say, as we know that the current always flow from in forward biasing, so there will no flow of current in cutoff mode of operation. We can say in cutoff mode of operation, no flow of current will be there. Okay. Third one is the saturation. The saturation current we can see is both are in the forward biasing. So emitter base it is also in forward biasing, and the collector base it is also in forward biasing. So as both are in forward biasing, so a huge amount of current will produce, and there will be huge amount of current will produce in the huge amount of current will produce in base region. Huge amount of current will produce in the base region. So it work as a switching. It works as switching on off in saturation. Okay. So we can say that the modes of operation is nothing but we can change the biasing of the function of the different region of transistor, and we can change the operation of the transistor. So this is the mode of operation, and the last one is the application where we use the BJT transistor. So first one is amplifier, as I said earlier, it used as an amplifier to get the amplified output. Switching circuit, as we said, in saturation mode, uh, switching happens. That means the huge amount of current produced in the base. So it works as a switching circuit, on off circuit. Third one is voltage regulator. It also uses voltage regulator as in regulator for fans. It used as to increase or decrease the voltage, to increase or decrease current also. Last one is the motor control. Motor control also it works. So these are the applications for BJT, and that's all for today. Thank you.